Hello everyone and welcome to another video on Indian Forest Service mains question, and today we are going to solve 2021 question of metal cutting and one another question of theoretical question. So first question is, a turning operation is performed on cylindrical workpiece using the following two tools. First one is HSS tool with nose radius 0.6 mm and another is carbide tool. So here we will write HSS tool and carbide tool. So HSS tool has nose radius R is equal to 0.6 mm and carbide tool having the side cutting edge angle sin S, that is 25 degree, and end cutting edge angle, that is psi E, that is 5 degree. Okay, and if feed for both the cases, that is 0.15 mm, feed is 0.15 mm. So calculate the maximum height of roughness obtained with HSS tool and carbide tool. Okay, so here this is the best question for which we can use the both the our roughness peak to valley height or maximum roughness equation. So H max equation, when nose radius is not equal to 0, then in that case our equation will be f square divided by 8r. So f will be 0.15 whole square divided by 8r. R will be 0.6. So when you solve this, you will get 4.68 micrometer. This is the maximum roughness height in HSS case, and your answer should be in micrometer. Your answer should be in micrometer, otherwise your answer will be not reflected in a better way, because roughness will be in always in indicated micron. Okay, so in examination keep this in mind. Next case, here when r is equal to 0, nose radius is not given, then h max equation will be given by f divided by cot and cutting edge angle plus 10 side cutting edge angle. So f is 0.15 mm divided by cot and cutting edge angle, that means cot 5 degree plus 10 25 degree. So when you solve this, you will get 12.6 micrometer. So this is the answer in both the cases. So you can say that this is a good example for the revision as well as your notes as well as your question practice for equation, because sometimes what happen, we know the equation but we don't know the how to apply. So this is the best example for application point of view, where you can understand how the questions formulas are applied in question. So this question is also useful for engineering service point of view as well as gate point of view and your civil services point of view also in mains, but the chances are very less in civil services, but they can ask. But the chances in gate are very high, as well as some PSU's exam where calculator is allowed or not allowed, but whatever. But this question can be asked in PSU exam also. Next question, this is a theory question from paper 2. Here mention the different factors to be considered for selecting the site of hydroelectric power plant. So here there are 6 factors that we have to consider for site selection. First one is, as it is a hydroelectric power plant, so first one is we have to consider availability of the water, because the capacity and the size of the power plant will be solely decided based on availability of water. And how we can decide the availability of water, that is runoff data, surface runoff data from civil engineering. Those who are in civil engineering, they know this thing, the runoff data as well as precipitation data, that means rainfall data of past few years, statistical data, rainfall. Okay, so from these two you can get the availability of water. So based on this we can decide the capacity of the hydroelectric plant. Okay, then second thing, that is how much the peak load, like the level of water and availability of water is not constant throughout the year. So in rainy season, the quantity of water will be higher. So at that time, to meet the demand or to prevent from overflow or to prevent from breakage of dam or plant, we have to design on the peak load condition also. And also from designing of spillways. The spillway design is itself is another topic in civil engineering branch. So, or we can say that just overflow, whatever the excess water is there, and we have to spill it out. So the design in such a way that we have to the without damaging our dam, the way we are designing for excess water, that is called spillway. So based on the availability of water data, we can define three things: capacity of water, peak load, as well as spillway. Then second is water storage capacity. Okay, so water storage capacity, like if we have the rainfall data, then how much the reservoir, what is the capacity of reservoir that we need to design. If we have plenty of water throughout the year, so we have to design the reservoir very small quantity, but the small size. But in the area where the rainfall is very low or very less, or we can say that whenever rainfall comes, it will for very short duration. So in that case, we have to design the reservoir of bigger capacity. Okay, so these are uh, the second parameter. Then availability of water head, third thing. So availability of water head, from this point, why this is considered, because how much the power we can generate, how much power generation, because power generation in hydroelectric power plant, P is equal to rho g qh divided by overall efficiency. So this is directly proportional to, power is directly proportional to head of water. Okay, and if we convert q in terms of h also, then ultimately it will be converted into h power 3 by 2. So power is proportional to 3 by 2 power, that is 1.5 power of head. So that's why availability of water head is also as initial, and initially it is very needful. Then accessibility of site. Okay, like whether it is, how it is connected by rail or road, because if it is not connected by rail or road, then to build a hydroelectric power plant, initially we have to supply the raw materials as well as the civil heavy machineries and construction equipments there. So to transport that, we need some additional cost. So to prevent this, we need to check the accessibility of site, how much it is far, how much it is far or near from rail or road, or how well it is connected by rail or road transport. Because initially we require to transport the raw material, manpower, as well as our machineries but after that, our regular manpower, maintenance, and all the things that we needed, that should also be connected. Otherwise, your transmitted that transmission cost, sorry, not transmission but transportation cost, it's that the transportation cost will be high. Okay, the second is distance from load center, like how far it is connected. Load center is what, where the because what is the output, that is power, electricity. The main output of the hydroelectric power plant is electricity. So electricity, where it is to be used, whether it is to be industry or it is to be house, so how much they are far away from the your hydroelectric power plant. If they are too far, then our transmission cost during the power grid and transmission cables, so there are losses. So these losses are very high if the distance from a load and the generation is very high. If they are very less, if the distance is very less, or we can say that they are very close, so there is a chances of in rainy season, during the damage of the hydroelectric power plant, if in case happen, so at that time they also, industries or household area will also get affected. So it should be at moderate distance. The another thing that we have to think from the point of view, that is uh, area, the nearby people that are living, so whether they are affected or not, and we have to choose the site in such a manner that they should be affected in minimum manner, their livelihood should be not affected very much due to these power plants. Then types of land on the site. So the most preferable site is rock type, because the foundation of the dam is constructed on the very good soil. It should be on solid concrete soil. So the rock type soil is preferable, because we have to increase the enormous amount of load, static load as well as hydrodynamic load as well as the mechanical loads are there. We have to transfer on the ultimately on the land. So we have to prefer rock type soil. Okay. So this is the thing. These are the things that we have to take care in the while selecting the power plant location. I hope you understand this, and I will upload the other videos of mathematics as well as the shorts of GK. Okay, I will also upload that video in regular manner. So thank you for watching this video. I hope you enjoy this, and we will meet on next video. Till then, keep connected with us by subscribing us and share with your friends also, so that they will also get benefit. Thank you for